Today our focus on polygons is going to be about how to calculate the area of different types of polygons. Now first we're going to go over some basic definitions. So the area refers to the space inside a figure. It's the amount of surface that's covered by a figure. On the other hand, perimeter refers to the distance around a figure. You can think of it as how much fencing you need to put around that figure. Now remember also, before we get into these formulas, that when we refer to the base and the height of a polygon, they must always be perpendicular to each other. Alright, so next here, you're going to see all these area formulas. Now this is, in terms of the formula sheet that you get on the MCAS, is what it will look like. So the square, the area of a square, is s squared. The area of a rectangle, b times h, so base times height. Same with a parallelogram. A triangle is 1/2 base times height. A trapezoid is 1/2 the height times, in parentheses, b1 plus b2. And then the area of a circle, which actually is not a polygon, but that's how it is given to you on the MCAS, is equal to pi r squared. So just quickly here, so that you can see a visual along with each of these. So for a square, we have s, and that is the measure of the side. And remember, since all the sides are congruent, you just have one measurement there. So the area is s times s, or just s squared. For a rectangle, when we say base times height, you may have seen this in the past as length times width. Base times height particularly refers to the fact that those two measurements have to be perpendicular to each other. Now in a rectangle, that happens to be the length and the width of the rectangle. You can see here in the parallelogram, we still have base times height, but the height is still perpendicular to the base, and we're not using the length of the side of that parallelogram. So it's still base times height. All right, onto a triangle. So for a triangle, we have 1/2 base times height. And again, you can see here that the base and the height are perpendicular to each other. And then for the trapezoid, remember for a trapezoid, we call the two sides that are parallel to each other the bases. So we have base 1 on top and base 2 on the bottom. You would add those two together. And then you see here we have the height, which is perpendicular to both bases, since the bases are parallel to each other. And you find the area as 1/2 times the height times the sum of the bases. Alright, so then these two formulas that we're going to go over next are not given on the formula sheet on the MCAS. They are for the kite and the rhombus. So for the kite, we have 1/2 times d1 times d2. Now what are d1 and d2? They are simply the diagonals. So you can see here that d1 is the measure of that diagonal that's going down, and d2 is the one that's going across. Now for a rhombus, this is actually the same formula, 1/2 d1 times d2. Now since a rhombus is also a parallelogram, you actually could use the formula for a parallelogram instead. So there are actually two formulas you can use for the rhombus. It's a matter of what information you might already be given, and one formula might be easier than the other. Next, we're going to talk about what we call composite figures. So a composite figure is a figure that is made up of one or more basic figures. Now there are two methods. Two methods of doing this. First is you can take the shape that you have and divide it into all of its basic shapes and add their areas together. So for example, for this here, this giant shape, we can break down into, it looks like two different triangles and a parallelogram. So that's one way to do it. You can divide it into those shapes, find the areas of each of those shapes, and add them together. The second method is to find the area of the entire shape and subtract out any missing pieces. So here's an example. This looks like a square with a triangle taken out. Now it's probably easier to see it that way than to break it down into more shapes. If you were to divide it out, you might need to find areas that are more difficult to find. So for example, you could divide this into 2 separate trapezoids, but you also might not have all the information that you need. So it seems that here it might be easier to find the area of the square and then subtract out the area of the triangle. Let's take a look at an example. So here we have parallelogram PQRS. For trying to find the area, we need to find the base and the height. Now this is a matter of what you see as the base and the height. You could see that the base is PQ and the height is QT. Those two are in fact perpendicular to each other. So you could find that this is 12 times 4, which is equal to 48. Now that's not the only way you can see the base and the height. You can see here that the base could also be PS, and then the height would have to be perpendicular to it. In this case would be 8. You can see there on the far right. So you could also find it that way, and you would find that this would be 6 times 8, which is also equal to 48. So the area is definitely 48 units squared. In both cases, notice that the base and the height that were used are perpendicular to each other. Alright, here's our next example. Find the perimeter and area of the polygon. So first we notice that we have a triangle. It's a right triangle. To find the perimeter, we need to know what that last side is. So we can use the Pythagorean theorem, since we have a right triangle, to find the missing side. That would be 5 squared plus x squared equals 13 squared. If you remember your Pythagorean triples, you can easily get x from here, but if you don't remember, you can go ahead and simplify this and get that x is equal to 12. Now to find the perimeter, we would have to add all the sides. That would be 12 plus 5 plus 13, which is equal to 30. And then we need to find the area of the triangle as well. So the area of a triangle, remember, is 1/2 base times height. And remember that the base and the height must be perpendicular to one another. So we see that the height is 5 and the base must be perpendicular to it, so that must be the 12. So that would be 1/2 times 12 times 5, which is equal to 30 units squared. Okay, in this next example, it says the base of a triangle is twice its height. The area of the triangle is 36 square inches. Find the base and height. So here we can see that the height is given as h and the base is given as 2h. That's exactly what it says when it says the base of the triangle is twice its height. Now we're also told the area of the triangle is 36 square inches. Remember how to find the area of a triangle? That's 1/2 base times height. So we can substitute everything we know into that formula. So the area is given as 36, the base is 2h, and the height is h. Simplifying this, we end up with 36 equals h squared, which means h must be equal to 6. Now the problem is asking us to not only find the height, but to also find the base. So the height is 6, and then the base, remember, is twice the height, so 2h, which would be 2 times 6, which is equal to 12. Okay, in our next example, the free throw lane on an international basketball court is shaped like a trapezoid. Find the area of the free throw lane. So remember, the area of a trapezoid is 1/2 times the height times base 1 plus base 2. The bases are the sides that are parallel to each other. So in this case, the 3.6 meters and the 6 meters, those are our bases. And the height is the one that is perpendicular to the two bases. That would be 5.8. So substituting into that, we end up with 1/2 times 5.8, times 6 plus 3.6. And simplifying this, we end up with 27.84 square meters. All right, we have one last example. One diagonal of a kite is twice as long as the other diagonal. The area of the kite is 72.25 square inches. What are the lengths of the diagonals? Now remember, the area of a kite is 1/2 times d1 times d2. We're told the area is 72.25 square inches. And we also know that one diagonal is twice as long as the other diagonal. So I'm going to call one of the diagonals D and the other diagonal 2D. Now I can simplify, and we have 1/2 times 2D squared on the right. The 1/2 and the 2 cancel. And if we were to take the square root of both sides, we end up with D equals 8.5. Now it does ask you for both diagonals, which we know are different. So one diagonal is 8.5, and the other diagonal is 2D, so that would be 2 times 8.5, and so that would be 17 inches. So the two diagonals are 8.5 inches and 17 inches.